All right. So here we are with Chapter 8, Advanced Network Security in Google Cloud Platform. So Advanced Network Security in Google Cloud Platform encompasses several key areas: private Google access, identity-aware proxy, Cloud NAT, and Cloud Armor. These technologies work together to provide context-aware security and establish a comprehensive secure cloud environment. VPC, the virtual private cloud, defines a context owner approach to securing cloud resources, such as web applications and web application firewalls, while services like Cloud Armor protect the environment from distributed denial of service DDoS attacks. In this chapter, we'll explore critical network security components in depth, including their configuration, benefits, and best practices for implementation. All right. So, first up, we're going to go into private Google access. Okay. All right, and I'll show you this in the chat, but understanding the challenge. Private Google Access addresses a fundamental challenge, enabling virtual machines and Google Compute Engines instances without external IP addresses to access Google APIs and services. By default, instances without public IP addresses cannot access Google Cloud application endpoints. Virtual machines often need to communicate with managed services like Google Cloud Storage, BigQuery, and other Google Cloud services. These managed services have public endpoints such as storage.googleapis.com that typically require external access. However, assigning an external IP address to every virtual machine that needs to communicate with these public APIs is neither practical nor secure, especially given the scarcity of IPv4 addresses. IPv4 addresses. How private Google Access works. Private Google Access provides a solution by enabling communications with Google API public endpoints without requiring external IP addresses. Additionally, when interconnecting with on-premises environments through cloud VPNs or cloud interconnect, private Google Access can be extended to allow access from on-premises systems to Google APIs through internal networks. I'll see if I can get a good image to show you how this works. Oops. There you go. All right. So private Google access is enabled on a subnet by subnet basis through the VPC subnet settings. So let's understand this with an example. Consider a VPC with two subnets, subnet A and subnet B. These contain four virtual machines. Virtual machines 1 and 2 are in subnet A, which has private Google access enabled. Virtual machines 3 and 4 are in subnet B, which does not have private Google access. Virtual machines 1 and 3 have only private IP addresses. Virtual machines 2 and 4 have external IP addresses. In this scenario, virtual machine 1 can access Google APIs because it's in a subnet A with private Google access enabled. Virtual machine 3 cannot access Google APIs because it only has a private IP address and is in subnet B, which does not have private Google access enabled. Virtual machines 2 and 4 can access Google APIs regardless of subnet configuration because they have external IP addresses. So what's the purpose of private Google access? It allows virtual machine instances without external IP addresses to access Google APIs and services. Let's show you how we can do this in the GUI. One, click on the hamburger menu, go down to VPC Networks, and then let's see. Um, okay, let's see. Where would it be? Let me try. Why am I not seeing this? Okay, so let's say the subnets. All right. Oops, subnets. Let's see over here. Okay, so here we do see private Google access. Let's see. Off, off, off. Let's see if I can click this. Or actually, it might work on the other network because I think it only has one instead of it's a custom mode. Let's try this. Click on the subnet, click edit. Now we probably could do this in both of them. In private Google access, we click on, right, to enable it, and then we'd save. All right, and from here, we'll be able to access what we need in private Google access in our system without necessarily requiring an external IP. Okay, so from here, let's see if we can click this, edit, and you would be able to click on as well, even in auto mode. So that's good. Okay, so you can also create this in the CLI by doing the following. Right, gcloud compute networks subnets update the subnet name in the region and then enable private IP Google access. Okay. All right. So configuration requirements. To configure private Google access for your subnets, you must meet these prerequisites. Virtual machine instance interfaces should be in a subnet with a private Google access enabled. External IP addresses should not be assigned to virtual machines. The source IP address of the traffic packets must match the IP address of the primary interface of the virtual machines, or an internal IP address that has an alias IP range. Additionally, you have to satisfy the following. Private Google access can only be enabled on VPC networks. Legacy networks are not supported. Enabling private Google access does not automatically enable it for all APIs. You must select which APIs need private Google access. When using private.googleapis.com or restricted.googleapis.com domain names, you need DNS records to direct traffic to the IP addresses associated with these domains. You must configure a route to the public endpoints with the default internet gateway as the next hop. Egress firewall rules must be set to permit traffic to IP address ranges used by Google APIs and services. And you must correct network administration IAM permissions are required for configuration. While enabling private Google access is relatively simple, it requires understanding how Google Cloud DNS service and routing options are configured based on the available options and firewall rules. Let's go to, so next is DNS configuration. Okay. Let's see. With this. We'll store this. All right. So we'll have this. So depending on whether you choose restricted.googleapis.com or private.googleapis.com, you must ensure virtual machines in your VPC can resolve DNS requests to .googleapis.com and .gcr.im. So to do this, one, you create a DNS zone for Google APIs, googleapis.com using Cloud DNS Private Zone. All right. When creating a record in the googleapis.com zone, select one of the following. All right, so let's just say that. Oh, okay. One, you would select an A record for private.googleapis.com to point to the following. These following IP ranges. Okay. So it's 199.36.153.8.9.10 and .11. And you need an A record for restricted.googleapis.com pointing to the following. That's 199.36.153.4.5.6 and .7, right? And you can use Cloud DNS to add records to the Google API's private zone. Okay, so this will be done here. In the googleapis.com zone, create a CNAME record for googleapis.com that points to whichever A record you created in the previous step. All right. So for other Google API domain servers like .gcr.io, .gstatus.com, package pkg.dev, and pki.google, you can create DNS private zones with Cloud DNS, including both A records and CNAME records. Routing options. There are two main routing configurations for private Google access. One, using the default internet gateway, and two, creating a custom route. VPC networks come pre-configured with routing that includes the default gateway. Virtual machines have a default internet gateway where packets are sent when requesting access to Google APIs. Although default internet gateways suggest all internet traffic is sent to the public internet, this isn't completely accurate. The default internet gateway routes traffic from virtual machines to Google APIs within Google's network. Google doesn't allow routing to Google APIs and services through other virtual machine instances or custom next hops. If your VPC has a default route pointing to the default internet gateway, you can route all requests from virtual machines to the Google APIs and services without configuring the custom routes. However, you can create custom routes and define the next hop in use cases where you want to direct traffic to Cloud VPN or internal load balancers. All right, so next up, firewall rules. Okay. All right, so firewalls. All right, VPC instances require firewall rules that allow virtual machines to access the IP addresses used by Google APIs and services. Every VPC has two implied firewall rules that permit outgoing connections and block incoming connections. The implied allow egress rule satisfies this requirement for private Google access. Identity aware proxy. Okay. So identity aware proxy, IAP. Let's see if we can find this. There we go. Okay, so identity-aware proxy enables centralized authorization management for secure remote access to virtual machines and applications. IAP and load balancers sit in front of all data requests, providing simpler administration with less operational overhead compared to traditional VPN solutions. With IAP, there's no VPN to implement and no VPN clients to install and maintain. This streamlines the end user experience as users no longer need to launch a VPN client and sign into the VPN. How IAP works. So identity-aware proxy implements application-based access control rather than network-based access control. The access is only possible through IAP by users who have been configured with the appropriate IAM role. Authentication is performed via Google Cloud Identity or a federated identity provider, including support for two-factor authentication. To configure authorization with Cloud IAM, users need the identity-aware proxy secured web application user role on the resource project. So here's how we'll do this. We showed you to enable it. Go to identity-aware proxy. And then, oh, I have to configure this. Let's see if I do this. So I have to enter app information to create this for auth configuration. Well, from here, I would also have to configure the IAM roles. And I'll include this in the chat as well for anyone looking at this. But here's the complete IAM documentation. All right. And you can also enable IAP for a backend service in the CLI. Okay, so we'll connect here. Okay, and it'll be done. Okay, it'll be done with the following command. G-Cloud compute backend dash services update, and then the backend service name, and then IAP equals enabled, and then OAuth2 client ID, and then enter that client ID, OAuth2 client secret, enter that client secret, and then set it to global, right? And this would be good. So what are IAP's capabilities and integration? With IAP, you can secure resources running on a Google Compute Engine, Google App Engine, Google Kubernetes Engine, and even resources hosted on-premises or in third-party cloud providers. IAP integrates tightly with other Google Cloud projects like Cloud IAM, Cloud Identity, and Access Context Manager. Using Access Context Manager, you can enforce additional security checks when granting access to users. For example, you can check geolocation, enforce IP address whitelisting, and perform endpoint device checks, such as verifying allowed operating systems, checking for X.509 certificates, or confirming disk encryption. Okay, authentication and authorization process. These additional controls provide visibility into user context and aspects like single and multi-factor authentication, and also perform device checks before access is granted. The authentication server uses the required credentials to determine a user's identity, their email and user ID, if they are legitimate. Once authenticated, the authentication server examines the IAM roles to determine if the user is allowed to access the requested resources. When an application or resource is protected by IAP, only users with the appropriate IAM roles, specifically the IAP secured web application user role, can access it. To access protected resources, IAP runs both authentication and authorization checks. When IAP is enabled for a service, only IAP credentials that appear in the required headers or cookies are submitted to the authentication server. If a user doesn't have browser credentials, they're redirected to an OAuth 2.0 Google account sign-in. That flow stores a token for future sign-ins. Security considerations. GKE and GCE users can bypass IAP authentication if they access virtual machine application serving ports directly. IAP secured applications cannot be fully protected from code executing on different virtual machines, such as a firewall restriction cannot prevent this access. Similar considerations apply to Cloud Run. If a user has an auto-assigned URL, they can bypass IAP authentication. To safeguard against traffic that doesn't originate from the serving infrastructure, you must implement firewall rules and a load balancer. Alternatively, ingress controls for Cloud Run and App Engine can be used to verify signed headers. IAP for on-premises applications. IAP can also be extended to on-premises applications with a workflow similar to IAP on App Engine. The authentication and authorization checks performed for users are identical. The request is sent to an IAP connector that forwards it to the on-premises network over a site-to-site connection established by Cloud Interconnect. IAP targets on-premises applications through the IAP connector, which can be created from the IAP dashboard in the Google Cloud Console. The IAP connector is deployed using a configurable Google Cloud Deployment Manager template, which creates the resources needed to host and run the connector. Within the Google Cloud project, the template deploys an Ambassador proxy on a GKE cluster. The proxy routes traffic secured by IAP to on-premises applications by indirectly applying Google Cloud IAM access policies. Each routing name defined by routing parameters for IAP connectors must correspond to Ambassador-created GCE backend resources. The mapping parameter defines routing rules with source and destination, ensuring requests can be routed from the source to the correct destination, such as an application or an on-premises network. We'll get you some resources for that. Okay. And add these into the chat. Anyone who needs to look can go into that. All right. Okay. So identity options and use cases. By default, IAP integrates with Google identities and uses services like Google Cloud Identity and Cloud IAM. However, you can use external identities instead of the Google Cloud Identity Platform. IAP use cases are primarily limited to supporting applications with HTTP or HTTPS protocols, but you can use TCP forwarding to support SSH, Secure Cell, or RDP, Remote Desktop Protocol. So TCP tunneling with IAP. Users can connect to any TCP port on GCE via TCP forwarding. IAP opens a listening port and sends all traffic to the chosen instance. IAP uses HTTPS to encrypt all client-side traffic. The G-Cloud Compute SSH command contains SSH in HTTPS and passes it to the remote instance, eliminating the need for a streaming port when using SSH with G-Cloud. TCP forwarding only works with GCE instances using IAP and not with on-premises applications. For TCP tunneling, your instance settings must permit it when using the G-Cloud Compute SSH Instance 1 command. IAP TCP tunneling is used automatically if an external IP address isn't provided by the instance. If the instance has an external IP address, IAP TCP tunneling is bypassed in favor of the external IP address unless they use the following command, --tunnel -through -IAP. You'll see it here. This flag. Okay. All right. And that flag will force G-Cloud Compute SSH to always use IAP TCP tunneling. Okay. So we'll go to CloudNet. All right. So Google Cloud's implementation of network address translation, NAT, differs from traditional NAT architectures. Cloud NAT is a managed service offering high availability and seamless scalability. It allows outbound connections to the internet, but inbound traffic is permitted only in response to connections initiated by an instance. Cloud NAT is a regional resource that is fully distributed, software defined. There are no intermediate NAT proxies in the data path. The NAT configuration is stored in the control plane and pushed to the hosts, ensuring NAT continues to function regardless of control plane state with no performance bottlenecks or choke points. So there's some features and limitations, right? Cloud NAT supports alias IPs on virtual machines and relies on the default internet route in the VPC. There are certain cases where NAT isn't performed despite being configured. 1. When the virtual machine has an external IP. 2. When the default internet route has been changed. 3. During communications between backend virtual machines and a load balancer proxy. And 4. When communicating with Google APIs if private Google access is used instead. So let's show you how to create a NAT, right? So here's an example of how to create this. So we have the VPC and we have the subnet. Let's see, we can create a virtual machine real quick. Oh, we'll already use that one. Okay. Oops, get started. We'll just use that name. On Cloud Router, let's see, do we already have one? Okay, we'll use that network. And we'll use US East 1. In Cloud Router, we don't have one. So let's create a new one. All right. Description, BGP, that'll be okay. We'll click create. No, we'll just click cancel. But we would add that. And then map this to VM instances. And then click create. All right. We're going to cancel that. And it can also be done via the CLI with the Cloud Router first. You enter G-Cloud Compute routers, create, then the router name, and then the network equals the network name, and the region will be the region you're creating it for, right? And then you could create a NAT in configuration on the router with the following. With G-Cloud Compute routers, NATs create, and the NAT name, with the router equal the router name that you just created, and then the region with the region, and the NAT all subnets IP ranges, auto allocate the IPs, all right? All right. Okay. Next up, we'll go into Cloud Armor. Okay, so this is policies, here's the services, and here's the product overview. And I'll add that to the chat. All right. So Cloud Armor provides DDoS protection and web application WAF capabilities for web-based security of your infrastructure. It protects against DDoS attacks, cross-site scripting, SQL injections, and other threats. Some protections are automated while others require manual configuration. Cloud Armor leverages Google's global and distributed infrastructure to detect and absorb attacks and filter traffic through configurable security policies at the edge. Several features are only available for applications running behind HTTPS load balancer. So the purpose of it, DDoS protection, WAF capabilities to secure application threats. But how do you do this? So we're at the Cloud Armor section. So one, you can see the tiers of Cloud Armor for the standard, enterprise, and enterprise annual, right? First thing you do, go to the policy, click create policy, enter name. Let's just go to that one. All right, choose the policy type. Let's say a back-end security. Set a default scope. Let's go for global. So it's the policy layer, application or network, and a rule action denied. And then the response code, set this on here. And you can add additional rules, right? And these will be seen here, right? For basic IP mode with the action R, keep going, right? Go to the next step. Go, excuse me. And apply to certain targets, like here, for the certain resources. And then you can do a couple of advanced configurations. This is where you start getting into, what do you call it, advanced firewalling, and you start to have adaptive protection, right? It has a little more statefulness, and you'll be good. And then you click create the policy, all right? And we're gonna hit cancel. We'll be okay, all right? And you can do this via the CLI, all right? So show this. And you can enter the following: gcloud compute security dash policies create policy name, and then I have a description. All right. And you can also add a rule to the policy with the following. Okay. gcloud compute security dash policies rule create, and then the priority, and then you enter the policy name that you're attaching to, the expression, the action, and the rule description. All right. And then you can attach the policy to the backend service with the following. All right, gcloud compute backend services, backend dash services, update backend service name, and then the security policy you're attaching to, and then how you would set it for global. All right. So there's certain protection capabilities. All right. There are layer 3 and layer 4 protections built into Cloud Armor that don't require user configurations. These protect against volume-centric attacks such as DNS amplification, SYN floods, and slow loris attacks and more. Right? Cloud Armor is inline and scales with Google's global network. It protects applications and services behind external HTTPS load balancers, SSL proxy load balancers, or TCP proxy load balancers from volumetric DDoS attacks as a network or at the network or protocol level. By detecting and countering network threats, Cloud Armor's load balancer proxies only allow properly formatted requests. Custom layer 7 filtering policies, including pre-configured WAF rules to mitigate OWASP top 10 web application vulnerabilities, are available for backend services behind HTTPS load balancers. Google Cloud Edge can be used to define rules that enable or restrict access to external HTTPS load balancers as close as possible to the source of incoming traffic through security policies. And so we showed the service tiers earlier. Cloud Armor is available in several tiers, right? There's the Managed Protection Standard, the Managed Protection Plus, and now there's the Enterprise level. So the key difference between them is the DDoS response time and the cost protection that Plus provides compared to the standard. and there's no real difference in the product's capabilities. So there's integration with content delivery network, aka the CDN. So Cloud Armor can protect backend servers by enforcing security policies on dynamic requests and cache misses destined for CDN origin servers. Most applications are complex, serving both cacheable static content and dynamic requests. Cloud Armor inspects and filters requests sent to the origin server of a CDN, helping to prevent cache busting attacks that attempt to bypass the cache and force origin servers to send updated content. Additionally, Cloud Armor can protect dynamic portions of sites and applications from most common security vulnerabilities with rules defined by OWASP. For consistent security controls across applications, regardless of deployment location, whether in Google Cloud or hybrid configuration, network endpoint groups, NEGs, allow you to leverage Google Edge infrastructure, including load balancers, Cloud CDN, and Cloud Armor to protect websites or applications wherever they're hosted. With GKE ingress support for Cloud Armor, you can protect containerized workloads by placing them behind Google Global Load Balancers and configuring Cloud Armor security policies for layer 7 filtering and WAF user resources. So, more on security policies, right? So security policies can defend an application behind load balancers and against DDoS and other web-based attacks, whether deployed on Google Cloud or in hybrid or multi-cloud architectures. You can stop traffic before it reaches the load balancers backend services or backend buckets by using security policies that filter layer 3 and layer 7 requests. Conditions used for filters include IP addresses, IP ranges, region codes, and request headers. Right? Backend services behind an external load balancer can only access security policies for those specific services. Supported backend services include instance groups, serverless NEGs, internet NEGs for external services, and Google Cloud storage buckets. This extends to App Engine, Cloud Run, and Cloud Functions through serverless NEGs. For hybrid or multi-cloud protection needs, you must use internet NEGs. Security policies can only be applied when the load balancer is an external HTTPS load balancer. And then the backend services extend the load balancer scheme, and the backend services protocols meets the requirements, like HTTP, HTTPS, or HTTP2, right? There are two categories of security policies you can configure. One, backend security policies, and two, edge security policies. Instance applications, or NEGs, including internet, zonal, or serverless NEGs, can be used to filter and protect backend services. Actions associated with backend security policies include allow, deny, redirect to, let's say, Google reCAPTCHA, throttle, and rate-based ban for each service, IP range, or geography. You can create WAF rules, IP lists, layer 7 filtering, and adaptive protection capabilities through adaptive protection. Though, remember, adaptive protection is currently considered out of scope for the exam, but that might change, right? So for edge security policies, you can create allow deny rules based on source IP and source geography. These policies control access and filtering for cached information. So edge security policies offer more limiting filtering criteria compared to backend security rules. And a backend policy cannot be used as an edge security policy. Edge security measures are implemented at the edge of Google's network, upstream of the cloud CDN cache. Backend security policies and edge security policies can coexist to provide two levels of security protection. And policies can be applied simultaneously regardless of the resources that a backend service refers to, whether it's instance groups or network endpoint groups, right? But to secure backend buckets, you must use edge security policies. Note that edge security policies are examined and executed before identity-aware proxy, meaning an edge security policy will block a request before IAP can evaluate the identity of the requester. So about rule evaluation of priority. Rule evaluation order for security policies is determined by rule priority, right? The rule with the lowest numerical value has the highest priority and is evaluated first. If none of the higher priority rules match, a default rule is applied. Although the default rule cannot be deleted, you can change its associated action from allow to deny. Cloud Armor uses custom rule languages to define expressions and match conditions. When a request is received, Cloud Armor analyzes it against these expressions and either allows or denies inbound traffic based on whether the rules are met. Let's see, WAF rules. Let's find some stuff on WAF rules. Okay, I'll add these to the chat. Mhm. All right, so waffle rules. Cloud Armor offers both pre-configured waffles and the ability to create custom rules. You can create IP address allow list and deny list rules that support both IPv4 and IPv6. Deny rules can result in various HTTP responses, including a 403 for unauthorized, 404 for access denied, or a 502 for bad gateway. HTTP 429 is an error code indicating that an application has exceeded a set number of requests, triggered by an action rule that lists requests within a time period. Pre-configured rules based on the OWASP mod security core rule set protect against common attacks like SQL injections, cross-site scripting, local file inclusion, remote file inclusion, or remote code execution, right? You can also use rate limiting rules to restrict requests per client based on thresholds you define, right? Or you can temporarily ban clients who exceed defined thresholds during a specific duration. And let's go to named IP lists. CloudArmor allows you to reference third-party maintained IP ranges and addresses within a security policy without having to specify each IP address individually. You can create a reference for an entire list containing multiple IP addresses to allow or deny. These are not security policies themselves, but can be specified within a policy. Custom named IP address lists cannot be created. Only third-party providers who partner with Google maintain these lists for the Google named IP list service. So my apologies for that confusion there. Cloudflare and Imperva are service providers who partner with Google Cloud to supply named IP lists. A security rule can be configured to permit communications only from IP addresses in these lists while blocking unauthorized traffic. So here's some key implementation steps. All right, so I'm going to clear off some space here. All right, so for private Google access, we showed you how to enable this on the subnet level. Okay, let's go back over this. All right, we went to the VPC network, click on the subnets, click on a specific subnet, edit, and you can enable this here, right? And you can make sure that you configure this for the appropriate endpoints, and then make sure that firewall rules permits this. Okay, let me open this one up, and then let's see, identity aware proxy. All right, here we go here. Configure this with the OAuth, and then be able to assign the role to the appropriate users, or the IAP secured web application user, that role to appropriate users. And then for on-premises applications, you deploy the IAP connector. And for TCP tunneling, you would use appropriate gcloud commands with the --tunnel -through -IAP flag when needed, right? And then for Cloud NAT, all right, here we go here. With your VPC network subnet created, you could create the NAT, set it up on your network, region, and create a cloud router. Oops. Right, and then create a cloud router. And then you configure a NAT gateway on the cloud NAT. Once you're done, all right, and then finally, Cloud Armor. From here, you remember to deploy this behind the HTTPS, SSL, or TCP proxy load balancers. And then you create the policy as needed based on your requirements for backend or edge, and configure the rules with, we're talking about the backend, edge, right? The regional, global, application, or network layer. And then you add your rules depending on what you need and be consistent with your priorities and actions. And for CDN integration, you could ensure that Cloud Armor protects origin servers. All right. So those are the big things. Now, remember, by implementing these advanced network features, you can create a comprehensive security posture for your Google Cloud environment. It'll address both external threats and internal access control requirements. But until then, you should practice with this and get ready for our next chapter, which will be on Google Cloud Key Management Service. Thank you, and have a good day.